Last time we were studying logic families and I explained you fan in, fan out. Now comes the timing. So let's suppose this is a NOT gate and we need to see its timing characteristics. We want to see how fast it is. So what we do, we apply a square wave which goes from high to low, and then its output, how its output will change. How do you think its output look like?
Low to high?
Low to high. Now we will put output and input on the same time axis, and we will note down the 50% value of the input, and we will note down the 50% value of the output and the mid value of both. Then we will see at what time input reaches 50% value, and that time is called T1, and we will note down the time on which output reaches its 50% value. So that time is called T2, and the difference between these two is called the propagation delay time. Your input signal goes inside the NOT gate and travels, and output signal appears at the output of the NOT gate. In this process, there is some time lag, and that time lag is called the propagation delay time. So I was considering only a signal which was initially high and then suddenly it becomes low. So this time when it is going from high to low, this period has to be very small. Practically it is in nanoseconds, this period going from high to low or from low to high, because a logic gate we prefer to apply only logic high and logic low. We don't want to be in the uncertain region. I told you uncertain region. This thing was uncertain region.
Yes, sir.
And we don't want to lie in the uncertain region. You know that signal must take some time when it comes from high to low or when it goes from low to high. But we want this period to be as small as possible. And secondly, there is other delay. Delay means processing time taken by the logic gate itself. Logic gate may input 50% value te ho at time t1. At time t2, इन जो output 50% value te है. तो हाणे इन में delay केतिरो थियो? t2 minus t1. This is propagation delay time. Means the time signal takes to travel through the gate. There are two types of propagation delay time. When output signal is going from low to high, so this is called tpLH because the output is going from low to high, and the time, another propagation delay time is when output is coming from high to low. So tpHL. Normally these two values are similar but not same. They vary slightly.
Yes, sir.
So in some technologies, tpLH may be greater than tpHL. In other technologies, tpHL will be greater than tpLH. So this, normally we do a lab to verify this in the laboratory. I will demonstrate you this thing on the oscilloscope. I will show you this delay and this delay.
Sir?
G.
Sir, tpLH and tpHL in one wave will be same?
No, they are never exactly the same, but they are similar values, very close to each other.
Why not same?
Yeah, because you are Nurulin?
Divya.
Divya. If I am ताके जेकरे चवा त तवा डाकण ता लहो त ता जल्दी लहंदा या चवा चढ़ो त जल्दी चढ़ंदा?
सर लहण टाइम जल्दी उतरंदम.
है न, लहण ते ता जल्दी लही वेंदा, चढ़ण ते ताके वक्त लगंदो. छो?
Sir, because against gravity one bend करें.
Of course. So now the two sides are never the same. The two
So, but
sides are never.
in a signal, what parameters affect? Because like in a regular life, we have gravity and resistance, but in a signal, there is nothing like that. What property does
No,
make this happen?
signal has to travel. See, for example, signal has to travel. For
So, but the
example,
resistivity
हिन
is
मिक्स
same
है
throughout the channel.
न न ईअं कोन्हे न ही ॾिसो आर बि
जी
हूंदो
sir.
आहे ऐं सी बि हूंदो आहे पाथ में
Yes sir.
ऐं ही जेको हेठि लहे पियो that depends on R and C both. तव्हां जॾहिं लॉजिक गेट डिज़ाइन कंदा आहियो न त हुन में रेजिस्टेंस बि हूंदो आहे पाथ में ऐं कैपेसिटेंस बि हूंदी आहे त सिग्नल कमिंग फ्रॉम हाई टू लो एंड लो टू हाई उन में ॿ मुख़्तलिफ़ पाथ इस्तेमालु थींदा आहिनि फॉर एग्जांपल दिस वन दिव्या
Yes sir.
हाई किथां मिलंदो हाई मिलंदो हितां आउटपुट
जी sir.
जे आउटपुट ऐं सोर्स जे विच में ही ॿ ट्रांजिस्टर आहिनि Q1
जी.
Q2 ऐं आउटपुट लो किथां मिलंदो हितां ग्राउंड खां
Ground.
इन जे विच में Q3 एंड Q4 आहिनि
Q4.
ही ॿ पैरेलल में आहिनि ही ॿ सीरीज में आहिनि
Yes sir.
ही PMOS आहे ही NMOS आहे even if their characteristics are same resistance are same capacitance are same even then see these two are in parallel these two are in series
Series.
त ही पाथ ॿियो आहे ही पाथ ॿियो आहे लो खां हाई वञण जो पाथ ॿियो आहे हाई खां लो वञण जो पाथ ॿियो आहे अच्छा वरी जेकॾहिं तव्हांखे 3 इनपुट गेट खपंदो त छा थींदो तव्हां हिते थर्ड ट्रांजिस्टर विझंदा
Transistor लड़ना.
अच्छा हिते थर्ड ट्रांजिस्टर वेंदो पैरेलल में हिते थर्ड ट्रांजिस्टर वेंदो सीरीज में
Series.
सीरीज में रेजिस्टेंस वधी वेंदो आहे
जी sir.
पैरेलल में रेजिस्टेंस घटिजी वेंदो आहे
Decrease थी वेंदो.
त लो टू हाई टाइम घटिजी वेंदो हाई टू लो टाइम वधी वेंदो
Okay sir, understood.
okay so normally some technologies are faster than other technologies so if you buy gates of two different technologies their propagation delay times will be different and even two gates of the same technology may be slightly different so generally tpL is considered faster than CMOS but remember that throughout last 50-60 years technologies have been changing means there are several variations of TTL and there are several variations of CMOS also. So not all TTL technologies may be faster than all CMOS technologies. But generally TTL is considered faster than CMOS. The faster mana the propagation delay times are smaller and slower mana propagation delay times are bigger. ठीक है? You applied an input. ही जेको input change थियो न माना तव्हां हिकिड़ो input apply करे छॾियो हिते वरी input change थियो माना you applied another input but remember you can apply another input here you cannot apply another input here no because it is too close the gate is still responding to the first input so you cannot apply second input here you need to wait the jetro propagation delay time नंढड़ो हूंदो ओतिरो quickly तव्हां next input ॾेई सघो था your processor will become faster your digital circuit will become faster you can apply new input very quickly if the propagation delay time is smaller जेकॾहिं propagation delay time जेतिरो वॾो हूंदो न ओतिरी तव्हांखे देरि लॻाइणी पवंदी new input ॾियण में so that will be slower circuit so oldest successful technology कहिड़ी आहे TTL it is considered as standard and it is fast इन जी वेरिएशंस जेके अॼुकल्ह इस्तेमालु थींदियूं आहिनि TTL जूं वेरिएशंस उहे कहिड़ियूं आहिनि ALS and F and complementary metal oxide semiconductor it requires low power consumption it is energy power dissipation low आहे as compared to TTL जेकॾहिं तव्हां हिकिड़ी IC में इलाही सारा ट्रांजिस्टर विझंदा तव्हां हिकिड़ी IC में इलाही सारा ट्रांजिस्टर छो विझंदा आहियो why would you like to put more and more transistors into one IC small IC
सर एम्प्लीफिकेशन जे लाइ
Oh no dear, to make things smaller in size, to make things portable. अॻे टीवी जेके हूंदा हुआ इलाही वॾा हूंदा हुआ, हाणे टीवी सेट्स इलाही स्लिम थी विया आहिनि, हा न. यू हैंग देम ऑन द वॉल. लाइट वेट. जेकॾहिं थोरी नंढड़ी आईसी में इलाही सारा ट्रांजिस्टर हूंदा त छा थींदो? इलाही गर्मी पैदा थींदी,
Heat.
इलाही गर्मी पैदा थींदी त आईसी सड़ी सघे थी.
Yes, sir.
इन करे पाण टेक्नोलॉजी खे टाइम सां इम्प्रूव पिया करियूं त जीअं पावर कंज़प्शन घटि थिए. पावर कंज़प्शन घटि थींदी आहे त छा थींदो आहे? बिजली घटि ख़र्च थींदी आहे, पर गर्मी बि घटि पैदा थींदी. गर्मी घटि पैदा थींदी त छा थींदो? रिलायबिलिटी वधंदी आईसी जी. अच्छा, उन खां सवाइ छा थींदो गर्मी घटि थियण सां? यू कैन पुट मोर ट्रांजिस्टर्स इन द स्मॉल एरिया. छाकाणि त हाणे उन्हनि में हीट घटि पई पैदा थिए त यू कैन ब्रिंग दी ट्रांजिस्टर्स क्लोज़र. HC छा आहे? इहा CMOS जी टेक्नोलॉजी आहे. HC मोस्ट कॉमनली यूज़्ड नाउअडेज़. त हाणे तव्हांखे IC नंबर कीअं मिलंदा? ओए 74S 74LS 74AS 74ALS 74F ऐं CMOS में 74C 74HC 74HCT. माना ही CMOS आहिनि, ठीकु आहे, ऐं ही TTL आहिनि. There are other technologies also, but they are less used and some of them are obsolete. We don't use them, and some of them are less commonly used. But most commonly used कहिड़ियूं आहिनि? TTL and CMOS.